Hi, Concepts of Algebra students. Today you are going to be adding a new section to your ISN. It is called Comparing Linear and Nonlinear Functions. I can't exactly remember what page we're on, so add it to the next 2 pages in your ISN. You can put today's date, February 23rd. So this is section 6.4 in our textbook. You can take the note sheet that I gave you, and you're going to first fold it in half and then fold your 2 sides from your halves into the center so that when you're done, you end up with this side folded in and then this side will be folded in as well. You can then cut on these lines if you would like so that you have 3 tabs here, and same thing on this side, 3 tabs here. So it should look something like that when you're done. You're going to start with both of these sides folded into the center so that there's nothing written on the outside. So now if you think about, this is the one side folded in, this is the other side folded in, this is what you're going to write on your outside. So on the left, this is where we're going to have examples of linear functions. We've talked about linear functions a lot recently. A linear function is a function with a constant rate of change. So if your x value is changing by 5, it will be constant. It will do that as every value changes. Same thing with your y value. Whatever your y value is changing by is constant. On the right-hand side will be our examples of nonlinear functions. This is a function that does not have a constant rate of change, so you won't see that constant change between every value. So you can start by opening up the 2 tabs at the top. We're going to start on the left-hand side with the example of the linear function table. So here's your table. So this is your tab that's open. Over here would be the other side of your note sheet. So we have this table. In order for us to decide if it's a linear function, we have to look at the rate of change. So we'll start with our x values. To go from 3 to 6, you are adding 3. From 6 to 9, you are adding 3. And from 9 to 12, you are adding 3. So we can label that. You should label this on your notes, showing that our rate of change for our x values is 3. We'll look at our y values now. From 40 to 32, we are subtracting 8. From 32 to 24, we are subtracting 8. From 24 to 16, we are subtracting 8. So again, we have a constant rate of change. You are constantly subtracting the same number from your y value and constantly adding the same number to your x value. So next to this table, you can write that as x increases by 3, y decreases by 8. The rate of change is constant, so the function is linear. So that's how you will decide if a table shows a linear function. See if the rate of change for both of your x and y values is constant. Now you can look at the right side of this tab. So here we have another table. Let's see if the rate of change in this table is constant. So from 1 to 3, we're adding 2. From 3 to 5, we're adding 2. And from 5 to 7, we're adding 2. So our rate of change in our x values is constant. Now let's check our y values. From 2 to 11, we're adding 9. But then from 11 to 33, we're adding 22. And from 33 to 88, we're adding 55. So the rate of change is not constant here. So we can say, write this down, as x increases by 2, y increases by different amounts. The rate of change is not constant, so the function is non-linear. So we checked the rate of change for our x values, we checked the rate of change for our y values, and we saw that our y values did not have a constant rate of change, so therefore the function is nonlinear. Now let's take a look at graphs. So you can go to the middle tabs. On the left-hand side, if you take a look at this graph, here it is. The graph is a line, so the function is linear. We've talked about the word linear meaning line, so with a graph you simply look to see if the graph is a line. Give you a second to write that down. Remember that for For an equation to be a function, or a relation to be a function, I should say, it cannot be vertical. So just keep in mind that we can't have a vertical line. So now take a look at the right-hand tab. Here, you look at this line. Actually, it's not a line. Therefore, the graph is not a line, so the function is not linear or non-linear. So anytime you see a curve, that's going to make it non-linear. And finally, we'll take a look at our equations. In order for an equation to represent a function, it must be able to be written in slope-intercept form. So we'll start on our left-hand tab. So we have three examples of equations here. We're going to see if they're already in slope-intercept form, and if they're not, we will change them into slope-intercept form. And if that is true for all of them, then they are all functions. So our first example, y equals 4.7, this is already in slope-intercept form. Then we have y equals 4 times x minus 1. Well, if we distribute the 4 to the x and distribute the 4 to the negative 1, we're going to get y equals 4x minus 4. That is in slope-intercept form. And finally, our last equation, y minus x equals 5. We can add x to both sides and we get y equals x plus 5. So all three of these equations can be written in slope-intercept form. Therefore, they are linear functions. So take a second to write that down. Each equation can be written in slope-intercept form, so they are linear functions. If they couldn't be written in slope-intercept form, then when we graph them, they would not form a line, so they would be nonlinear. Finally, we'll look at the last tab on the right-hand side. Looking at these equations, again, we're trying to see if they can be written in slope-intercept form. So let's take a look. So here we have y equals 4 divided by x. Since we're dividing 4 by x, that's not slope-intercept form because you need to be multiplying x by your slope. So therefore, it's already solved for y and it's not in slope-intercept form, so that would be a nonlinear function. Looking at our next example, y equals 1 minus x squared. This is already solved for y as well. And x squared is not part of our slope-intercept form. Our slope-intercept form should just have an x, or an x to the first power. So this will not be a linear function. And finally, our last example, I solved it for y over here. So I subtracted 3x squared from both sides and got y equals negative 3x squared plus 6. Again, we have that exponent next to the x, so we have negative 3x squared, and that is not slope-intercept form. So since you cannot write these equations in slope-intercept form, they are nonlinear functions. So copy down that final note. So remember slope-intercept form, y equals mx plus b. You should be multiplying your x value by some integer, and then you should have your y-intercept. So anything with an exponent is not written in slope-intercept form. Anything where you're dividing by x is not slope-intercept form. So let's recap everything we learned. For tables, to decide if they show a linear function, you're looking at the rate of change. So if the rate of change is constant in the function, if the rate of change is constant, sorry, typo here, the function is linear. If it is not constant, it is nonlinear. So look to see what your change in your x values are, look to see your change in y values, decide if it is constant or not. For graphs, if the graph is a line, the function is linear. If the graph is not a line, the function is nonlinear. So just look to see if there's a line or if there's curves. That will determine whether it is linear or nonlinear. And finally, in equations, if the equation can be written in slope-intercept form, the function is linear. If the equation cannot be written in slope-intercept form, the function is nonlinear. Okay, so that's how you can decide whether a function is linear or nonlinear. So hopefully you have an understanding of comparing linear and nonlinear functions. Tomorrow in class you will practice determining whether a function is linear or nonlinear. So I'll give you some tables, some graphs, some equations. You'll use your notes and you'll decide.